Hello and good morning, CSI257 Section 847 students for the first 8-week term for Networking 3 of the Spring 2015 semester at Anne Arundel Community College. Today's PacketTracer video tutorial is going to be on PacketTracer Activity 5.1.2.12, where we're going to be taking a look at determining the DR and the BDR and manipulating the election process and maybe changing some values here. So let's go ahead and talk a little bit about the DR and the BDR first and really why they're needed. So if you think about scalability, and in the image that we have over here we've only got 3 routers. So if each of these routers needed to establish an adjacency with all of the other routers, we end up dealing with that equation, which is n times n minus 1 divided by 2. So with 3 routers, we end up with 3 times 3 minus 1 divided by 2, or 6 divided by 2. We're going to have 3 adjacencies. Now, that doesn't seem like a lot. However, if you're in an environment where you've got, let's say, 17 routers, and then you need to figure out how many adjacencies are going to be established. You can see here it's going to be 17 times 16 divided by 2, and so let me pull my, I don't know what I did with the calculator here. I think I may have gotten rid of the calculator. Alright, we'll go old school. So 17 times 16, you've got 42, carrier 4, so we've got 10. And then we've got 6 and 7, so you're looking at 862 divided by 2, which is going to be 431. So you would have to maintain 431 adjacencies, right? And I guess after we divide by 2 it equals that. So 431 adjacencies. Now that's going to be 431 sets of LSAs that are going to have to be sent and received. So you would probably flood your network with LSA traffic alone and leaving little to no room for the actual data plane traffic. So that's why we have the DR and the BDR, is because you'll have one DR, and the DR is also referred to as a pseudo node, right? So it's actually running on one of the nodes, but it's considered a pseudo node. So you have your DR and all of the LSAs from all of the other clients. So everybody establishes an adjacency with the DR, and this is where all of the LSAs get sent, right, from all the other routers, router 3, we'll say router 2, right? All their LSAs are going to be sent to the DR, and if there's a BDR, it's the same case, right? Because the BDR needs to make sure that there's an orderly transition if the, I'll put the BDR here, if the DR fails. So all of the routers in the topology are going to send their LSAs to the DR, right? And then it's the DR's responsibility to then flood the LSAs back out, to flood those LSAs back out to everybody else who's in the topology, because 3 and 2, or router 2 and router 3, there is no adjacency established here with respect to the DR BDR process. So what ends up happening is the LSAs need to go to the DR first, and then the DR will distribute those LSAs out to everybody else. So let's go ahead and take a look at the election process and how we would set that up and what that's going to end up looking like. So in this activity, we're going to examine the DR and BDR roles and watch the roles change when there is a change in the network. So then we're going to modify the priority and we're going to try to control it. So let's verify the current OSPF neighbor states. So use the appropriate command on each router to examine the current DR and BDR. So we'll take a look at router A here. So let's bring these guys down. And this is also, while I'm opening these windows up, this is also why on point-to-point links, right? Typically on a serial link that's a point-to-point link, you're not going to have a DR-BDR election, because remember, the entire premise of the DR and BDR is to provide scalability, right? In an instance where you've got multiple routers and you're not going to be able to support tons of adjacencies, or you don't want to support tons of adjacencies, excuse me, in a point-to-point link, there are only 2 routers that are ever going to be on that point-to-point link. So that's why you don't see the BDR election process on a point-to-point link, because there will only ever be 2 things, and that, hence the name point-to-point. So let's go ahead. We'll go from user exec to privilege exec here, and I'm going to type show IP OSPF Neighbor, and this is going to show me the status, the current status for the BDR election process. Let's run that again. Yeah, interface names are kind of carrying over to the next line down. So as you can see, we have the neighbor ID, which is typically going to be the router ID. So we have a neighbor relationship here, and I'm on router A right now. The priority is 1, and that is the default priority. All right, so we'll put up here, that is the default priority for broadcast networks or multi-access networks. The default priority will be 1. On point-to-point networks, that default priority is 0, because again, 0 means you're not going to participate in the BDR election at all, and 1 is your default for multi-access segments, and it goes all the way up to 255. And 255 means I want that router to always come up and be the DR, right? Or to be, elected as the DR when possible. And we'll see there's some order of operations considerations we need to take into account as well. So the priority here, right, is 2. And obviously 2 is greater than 1. And so you can see here that it's full DR, that this is the state. There's a full adjacency established, and the role is the DR. We have the dead time. Now the dead time is very important, because if I run this command again, and let's switch over here. Let me clear the screen. So if I run that command again, the dead timer for broadcast networks by default is 40 seconds. So if I do a show IPOSPF Interface Gig 00, this is where I would see my timer values. So I've got the hello value at 10 seconds, the dead timer at 40, the wait at 40, and the retransmit at 5. So the dead timer, if the dead timer gets down to 0, the adjacency will be torn down. And we saw that in class on Saturday as we kind of watched it die and wither on the vine. So when I type show IPOSPF Neighbor, my dead time should never go below 30 seconds. Because again, if we're receiving, you see there it goes to 31 and then back up to 39. It's actually going from 30 to 40, but it's happening, we're not catching it right at that. There we go. We caught it at the 30, and then obviously we missed it going back up to 40. But the point is that every 10 seconds, a hello message goes from each of the routers to the other that it has an adjacency with, to ensure that the router is alive, right? So, and there we go, we got the 30, but then we missed the 40. So as you can see, it'll hit 30 seconds and then it goes right back up. As soon as it receives that hello, it's going to go right back to 40. If this number drops below 30 and you happen to catch that, that means that your hello packets on broadcast segments, right? And this is, you can see here the default OSPF network type on a broadcast segment here, multi-access segment, is going to be 40 seconds for the dead time and 10 seconds for the hello time, right? Okay, so back to the status. So you can see here that the state is full BDR with the neighbor 192.168.31.22, and we are full and the DR for 192.168.31.33. So if I were to type in show IPOSPF database, so if we were to take a look at the database, you can see here the link ID and the advertising router, it's typically the same value, right? And I say typically because you could, you could tweak your router ID to be a different value, but 99.9% of the time these are going to be identical, right? As you can see down here, the link ID for this guy is 192.168.1.3, and the advertising router comes up with a different value, right? So, but most of the time these are going to be the same value, typically a loopback address that's been configured, because the loopback address will never go down. So we've got the advertising router ID, right, 192.168.31.22. We have the age of the LSA. If I were to run the command again, you can see that the age is going to continue to count up. We have the sequence, and it starts out at 0x8000000 and then 1 for the first change, but now we have 2, right? So this number will continue to increment. You've got your checksum value, and then you have how many links, right, is this LSA. And again, when I type in show IP OSPF database, and then if I were to type in router, and it doesn't have the router command there. Let's see if it has any of the options. Yeah, unfortunately, it's only going to give us that. So if on the real iOS you were to type in router after that, you're going to get additional information. So it shows that we're in area 0. OSPF router with the ID 192.168.31.11, and our process ID is 1. So again, if I were to do the show run IP OSPF interface gig 00, and not show run, sorry, show IP OSPF interface gig 00, then we get some additional information here. So it shows us the designated router ID, and it shows us our router ID. So from this output, you can easily determine that the DR is out interface address 192.168.1.3, or that's the next hop address to get to the DR, and you can see right here that we are not the DR on router A. In fact, the backup designated router also has a different router ID, and that's the next hop interface to get to that router, and this is not us either. So when we do that show IP OSPF neighbor, right, this is showing, so these match up. The BDR is 22, and that's the ID of the BDR, and then the DR matches up with the process ID, or I'm sorry, the router ID for the DR. And so you can easily see and very quickly discern, okay, my relationship with 22, he's the BDR. My relationship with 33 is that he is the DR, right? And here are the interface addresses. So if I were to do a show IP interface brief, you can see that neither of these IPs is locally configured on me, right? I'm 192.168.1.1, so this is the address that I will go to reach those neighbors. All right, so we clearly see, to answer these questions here, right? And whoops, let me come back down. So which router is the DR? And that's going to be right now router 2, or I should say router B. And which router is the BDR? And that's going to be router C. And you can see here they've got the loopback addresses configured. And if I were to do a show run, so there's my loopback address, and chances are that that same loopback address 3111 is, and it's going to get picked up as the router ID, because remember with OSPF, if the router ID is not explicitly configured, which as a best practice, that's what you should be doing under the router OSPF 1 router config area, if that's not set, it's going to grab the highest IP address on any loopback. And so that's why we've picked up as our router ID, this is why we've picked up 192.168.31.11, 22, and 33. That's why we're seeing those when we type in that show IP OSPF neighbor, right? All right. So let's go to step 3. So it says turn on IP OSPF adjacency debugging. So debug IP OSPF adjacency, and we're going to turn that on all 3 of these guys. So we're going to say debug IPOSPF Adjacency, and we'll turn that on over here. Debug IPOSPF Adjacency. All right, so we've got, it didn't ask for it on C, but we'll keep it on C anyway. So now it says disable the link between RC, so router C, and the switch to cause the roles to change. So from router C's perspective, when I do a show IPOSPF Neighbor, and this is what I was talking about, you'll notice that router 11, or I should say, yeah, we'll say router A. So since router A is not the DR and it's not the BDR, his state is simply just DR other, and commonly you'll hear it referred to as just a druther, right? Which means that he is not the DR, he's not the BDR, he's just simply a druther. And then again, C sees router B as the BDR because we saw that from router A's perspective, right? So let's go ahead and take that interface down, and we're going to say do show IP interface brief. I think it's gig 00. It is. So we'll go from privilege exec into global config, and then into the interface configuration mode for gig 00, where we're going to say shut. And so you can see it immediately took the interface down, and we received some messages here, but what we're going to do is we're going to wait about 30 seconds for the dead timers to expire. So if I were to say, let me quickly move over here to router A, let's see if we can catch this. And I didn't want that. So there you have it. So take a look at that. So you can watch, you'll notice how the dead timer for the adjacency with the DR, router C, you can see it's slowly withering on the vine because we're not getting hellos because that adjacency is down. And so we're going to receive an error message that should actually tell us, or I should say a log message that as soon as that went down. So where is that? So here we go. So neighbor 192, and this is the router ID, right? 192.168.31.3 on gigabit Ethernet 00 from full to down, right? Because the dead timer has expired. So what's going to happen? We're going to have a new election process. So here we go. DR BDR election on gigabit Ethernet 00. So, and this is key, is that remember that the BDR is always elected first, right? And the reason for this is that there needs to be an orderly transition. So when OSPF first comes up, the BDR is going to be elected first, and then it will transition to the DR if in fact it is to become the DR. So we have this election take place. We've got our DR is elected as router B, 192.168.31.22, and then you can see here it says BDR. He's elected himself as the BDR as well. However, let's watch this as it transitions. So we're going to have another LSA. Let me clear the screen there. So we're going to have another set of LSAs that we received right here from router A, 3111. And so now we go through the BDR election process here again, where, and this is from the view of router A, is that it says elect BDR as router A, and the DR is going to be elected as router B. And then again, it just repeats it. It says the BDR and the DR because they're exchanging packets, and then we have our final election results. The DR ends up becoming router B, and the BDR becomes router A, right? So now, if I were to type in show IP OSPF Neighbor, we only have that one adjacency, and from router A's perspective, he sees router B, which is this is the router ID, that's the priority on the interface, and happens to be the default because we haven't changed that yet, and the state, it's a full state, and I see that neighbor, router B, as the DR. the designated router. This is the address that I would use to get, this is the DR's address, right? So that's the address I would use to get to that, and get to the DR. And then we have our dead time, which, as you can see, it's going to go down to 30, but now we're receiving hellos. So then it will continue to go back up. It'll increment it back to 40 and then count it down until it gets its next hello packet. So disable the link. We waited about 30 seconds. The timer's expired according to the debug output, which router was elected the DR and which was the BDR. So again, the higher loopback address, which is router B, was elected as the DR. However, it was elected as the DR because it was already the BDR. And so again, in order to ensure an orderly transition of the roles and responsibilities of the DR to the BDR, if the router is the BDR, even if router A had a better or a higher router ID or a higher priority, router B, who was the BDR, is still going to become the DR. And it's also important to note that if we were to bring router C back up right now, and I think it's going to have us do that, is that router C would not become the DR because this is a non-preemptive process. And so what that means is if I were to take router B down right now, or bring router C back up and then take A down or B down, A is going to become the DR because A is currently the BDR. So if I were to type show IPOSPF Interface Gig 00, we can see that the BDR is us, right? It shows it right there that we are the BDR. So if I brought C back up and let C come back up and let OSPF reconverge and stabilize, and then took down the interface on router B, router A would be the DR because he is currently the BDR. Router C would then take the rollover as the BDR. So let's continue on here. So step 4, we did that. So step 5, so restore. So good, we're going to restore the link on router C. So I'm already here, so now I'm going to say no shut, right? So this interface is going to come back up. We're going to see some messages on router B as well as router A, and so we're going to look at it from router A's perspective here. Or actually, let's look at it from router B's perspective. So as you can see, this is the end of the election process here between B and A. So now we're bringing C back online. Now C has a higher loopback address. He was the DR before we took his interface down. So let's see what ends up happening. So here's the generation of the link state advertisements. You can see C is coming back online. We've got the DR BDR election that router C is going to see. And however, take a look here. It's the exact same results. So router B will continue and maintain his DR status, show IPOSPF Neighbor, right? Router B will maintain, excuse me, his, or I'm actually on router B, I apologize. I'll come back over here to router C. So show IPOSPF Neighbor, do show IPOSPF Neighbor. So router B maintains his DR status, right? And router A maintains his BDR status because this is a non-preemptive process. All right, so it says wait for the new DR BDR elections to occur. Did DR and BDR roles change? Why or why not? So again, they did not because it's not a preemptive process. Even though C has a higher loopback address, a higher OSPF router ID, router A is the BDR, router B is the DR. They've already been elected. That's been established. So bringing router C online will be a non-intrusive event from the perspective of the DR BDR election, right? All right, so we restored that link. So now step 6, it says disable the gig 00 interface on router B. So we'll go to router B, and we're going to go into global config mode, and then interface config mode for gig 00, and I'm simply going to say shut. Now remember, we had talked before about this scenario happening, because right now router C is simply a druther. Router A was the BDR. So let's come over and let's take a look. And again, this is the result of our last election, right? The previous election, where it was simply reaffirmed that router B was the DR and router A was the BDR. But now let's see what happens when this link goes down. We're waiting for the dead timer to go down. And there we go. And do we see? Yeah, so the dead timer has gone all the way down. So now what's going to happen? We're going to have the DR BDR election process. It needs to be an orderly transition. And so then here are the results. So, excuse me. So again, if we take a look, let me scroll back up a little higher here. So as you can see, we've got the DR BDR elections going to take place. What's elected first? The BDR is elected first. So router C sends out his LSAs claiming to be the best advertisement, but he's not, right? Because there's already a DR. So he is elected as the BDR. So router C is the BDR because router A, who was the BDR, will transition to the DR. Then they send their LSAs out, right? The link state advertisements are then sent and received. And what do we end up with at the end is router A, right? 31.11, router A becomes the DR because he was the BDR. And router C, who was a druther, and since we don't have another BDR already, transitions to the role of BDR. Because again, remember, it is not a preemptive process, and it's not only is it not preemptive when we brought, remember we brought router C back online, and he was offline. We brought him back online, and A and B maintain their relationship as DR BDR, and their status, I should say, as DR BDR. There was never a change there, and so even though C was the DR previously and had a higher loopback or router ID, he did not preempt either one of those. And it's the same thing here. There's an election that takes place, and router C clearly has superior values as from the router ID perspective, higher router ID than router A. However, router A was already the BDR. So C cannot preempt router A and jump in there and steal the DR role. Okay, so we disabled the interface. It says wait about 30 seconds. We did. It says according to the debug, the DR is now router A and router C is our BDR. So let's restore the link. We're going to re-enable the link on router B. And remember, we've been talking about how this is a non-preemptive process. So B has a superior router ID to A, and B was just the DR. So let's see what happens when we bring that link up, and we'll look at it from router A's perspective. And so let's take a look at what else is going to be asked of us here. It says, wait for the new DR BDR elections to occur. Did DR and BDR roles change? Why or why not? So everything we've talked about to this point is telling us no, these roles are, in fact, not only are these roles not going to change, right? Router B is simply going to be put in the state of a druther, a DR other, and A will maintain his status as the DR, and C will maintain his status as the BDR. And so here is the election process, right? The database descriptor, the DBD, describing the database on router A is being sent. And let's take a look at what else we've got here. Excuse me. So the state changed to up. database descriptor, and actually we're on router A. I'm sorry, I keep thinking I'm on router B. So we're on router A. So A is sending a database descriptor packet so that B can update his link state database. So let's do a show IPOSPF neighbor now. And as you would expect, router 3 is still the BDR. Router B is simply DR other or a druther. And router A is still our DR. And again, if I do the show IPOSPF Interface Gig 00, this is where I can go to see what is the state, right? My state is DR. If I come over to router C and I run that same command, do show IPOSPF Interface Gig 00, what is my state? My state is BDR. And then it shows us the priority value as well. All right, so now let's go ahead and come down a little further here. I'm going to leave debugging on because I like the debug messages. I like to see what happens. It gives us additional talking points. So now we're going to change the DR and BDR. We're going to configure Ethernet 00 on each of the routers with the following values. So I am on router C, and I'm pretty sure I'm in gig 00, but let's make sure. So router C is going to get the default priority. However, is that the priority right now? If I do a do show run and we look at gig 00, you can see the IPOSPF priority was set to 2. So let's change that. We're going to say IPOSPF priority 1. And I believe what we could also do is simply say no IPOSPF priority 2 because 1 is the default. So if I do this, let's see if it shows us under the interface. Yeah, you can see it doesn't actually put that there because that's the default. So it's not going to show us what the value is because it's the default value, right? So I could have said no IPOSPF priority 2 and we would have ended up with the same result. Because if I were to do the do show IPOSPF interface gig 00 now, what is my priority? My priority is 1. Excuse me. All right, so let's come over to router B. Let's take a look at router B, and I'm going to make sure, I'm pretty sure it's gig 00, but let's make sure here. So I'm going to say IPOSPF priority, and for router B, it is going to be 100. Again, if I do a do show IPOSPF interface gig 00, take a look at that. Excuse me, my priority's changed already. Now again, remember that this is non-preemptive, and I try to stress that a lot because transitioning from spanning tree to where when you're making specific changes with spanning tree and that's taking effect immediately, with the DR BDR election process, it is not the same thing, right? This is not preemptive because again, we want to make sure we have an orderly transition from each of the possible states, the DR, the BDR, druther to a BDR, right? So we need an orderly transition, and this allows us to do that. You can see down here, neighbor count is 2, and router B says I'm adjacent with, and again, these are the router IDs. These are not, they've got them configured as loopback addresses, but these are the router IDs that are listed here. So the designated router is router 3111, which is router A, and router C is our BDR. So let's go change the last priority here, which is going to be router A. Whoops. And I'm going to say configure terminal to go to global config mode, and then interface gig 00. And we're going to say IPOSPF priority, and this one is going to be set to 200. So again, do show IPOSPF interface gig 00. And you can see that my priority has changed. My state, what am I? I'm the DR. And here are the neighbors whom I'm adjacent with. And you can see it doesn't even list the druther, right, as the state here. It just lists the backup designated router. All right, so we're going to force the election by doing a clear IPOSPF proc because, again, the DR BDR election is not going to redo itself unless we have some sort of an event that resets the OSPF process. So I'm going to go ahead and run this. We're going to say clear, clear IPOSPF proc. It should prompt us. We'll say yes, and I'm actually going to run this on all these guys. So do clear IPOSPF proc, and we'll say yes. And over here on router C, we're going to say do clear IPOSPF proc. Whoops. We'll say yes. See if I caught those quick enough. Excuse me. So again, we've got the database descriptor packets being sent back and forth, and now we have the election taking place for the DR and the BDR. And so as you can see here, let's go to router C because he's going to be kind of left out in the cold. You can see that the election process is taking place here, and initially router C, who is the BDR, right? You can see he elects himself as the BDR, but then as the packets are getting sent back and forth, he finds out that router B, who has a higher interface priority of 100 compared to his 1, is then going to be elected as the BDR. And then ultimately we end up with what we would expect is router A with the lowest router ID, right? So remember, this also proves that the interface priority, if you set the interface priority higher, and we do this clearing process here of the OSPF process, that the interface IPOSPF priority value, that is looked at before the router ID value is looked at. And we see that right here because router A, who has the lowest router ID, has been elected as the DR. And this is because we have that IPOSPF priority set to 200, IPOSPF Interface Gig 00. So let's take a look at the interface, and you can see, I'm sorry, I'm on router C. I saw 1 and I'm like, that is not what I was expecting to see. So show IPOSPF Interface Gig 00, and what do we see? Our priority is set to 200, and then we have been elected as the DR. We take a look at router B, do show IPOSPF Interface Gig 00. Again, our priority is 100, and we've been elected as the BDR. And then finally, router C, and there's not much new news here for router C. He is a druther, a DR other, waiting in the wings for another election to take place to see if maybe he can get promoted up to BDR. But his priority is 1. So again, the IPOSPF interface priority value is looked at before the router ID value. If the priorities are, given that all things are equal with the priorities, by default, if we just plug these guys in, the highest router ID would be elected as the DR, and then the second highest router ID would be your BDR. So we waited for everything to converge, and all right, so the new router, who is the DR, is router A, the BDR is router B, and our druther is router C. All right, so that concludes this activity about OSPF DR and BDR elections and how that process works. We got to take a look at the debug output, which gives us granular detail as to how OSPF is making its decisions. We looked at the priority value. We saw that the priority value, that higher is better. 255 would guarantee election as the DR, given that there are no values equal to that. And 0, we didn't get to see that because we don't have any serial links here, but 0 would indicate that that router is not going to participate at all in the election process. We could set one of these to 0 if we wanted to say, you know, maybe we want router B to not participate. We could set his priority to 0. If we cleared everything, it would be between router A and router C for the election of DR and BDR. So remember, multi-access segments, it's going to be, or broadcast type networks, you're going to have a default priority of 1. On point-to-point networks, specifically when you're looking at your serial links between routers, your default priority is going to be 0 because, again, there's no need for a centralized collection point of router LSAs, i.e. the DR and the BDR, because you're only ever going to have 2 neighbors on that link. And so that concludes PacketTracer Activity 5.1.2.12, and hopefully this has cleared up any confusion you might have had, and thank you for watching. I'll see you guys on Saturday.